Hey, what up, guys? It is Nick the Quant. Today we got another post for today's highest mathematical edge pick. Yesterday I gave you guys the Cincinnati Reds on the money line that cashed. And as always, if you want access to all of my free sports betting picks, you can go to my X account at NickTheQuant44, where I post all my daily picks the moment I run my model on my plays. Whatever picks have edge, I post immediately on my X account. I offer insight into what the model probabilities are, what the expected values are, and even how much I'm risking by using Kelly Criterion, which is risk sizing based off a probabilistic edge. So getting into that, we can now just get right into today's pick, and then I'll break down the math. So today's highest edge pick is the San Francisco Giants money line. I got them at plus, it depends. I think I got them like right around plus 119, but at different books, there's always variance between different books. So I would try to shop if you could and try to get them as the highest price possible. But DraftKings had them, I think, at like plus 119, if I'm not mistaken. My model has them at a 55.73% probability. So already you can see we've got mathematical edge, especially since they're an underdog, but significant pricing edges. They are a pretty decent underdog, and I've got them at a 55.73% probability. The Giants, therefore, then have 18.7% expected value, and I'm risking 2.75%, which for me is 2.75 units. 1% of my bankroll is 1 unit. So if I was risking 1%, then I'm risking 1 unit. So we can just jump right into the math on the pick. Before I do this real quick, I always like to kind of rehash this in case you're a new viewer. My ensemble model has 9 interior models. They're all calibrated based on the empirical outcomes of the initial predictions. So what that means is if the initial prediction of a model says 55%, but that prediction is accurate 60% of the time, then the calibrated probability, meaning the finalized probability of that model, is a 60%, not a 55%. And it's the same the other way. If it's underperforming and it's only hitting 45% of the time, then the calibrated probability is 45% of the time. So that happens across all 9 models. The ensemble model runs, you get an initial ensemble model output, and then that's calibrated based on how those initial probabilistic predictions perform in the real world, given that empirical data. But my second layer calibration, I use what's called empirical Bayes calibration, which means it takes into account that initial output, and then it takes into account the actual performance in the real world and the weighting of the calibration. So how much the calibration is going to rely on the initial model output or the actual real world data relies on the amount of sample size. So the more games that initial probability or that probability range has, the more volume there is, you can start to now rely more on the empirical data because that's what's actually happening. But if you don't have a lot of data yet, then you might be relying on the model a bit more, but you should be right around here, for a little bit at least, unless it's significantly overperforming or significantly underperforming. But as the more data you have, that's the whole goal with understanding the true reality of a probability distribution, is you're relying on that real world data. So I use empirical Bayes calibration for the second layer, and the third layer of calibration is based off of what the market region is that the team is in. So I'm going to get into all that right now, just in case you're a new viewer. Want to be transparent, obviously. So the first model had the Diamondbacks initially at a 60%, but that's only been hitting at a 50.94%. So model 1, Diamondbacks 50.94. Model 2 also had the Diamondbacks at a 60%. That's been hitting an 84.62% hit rate. So model 2, 84.62. And I forgot to mention this, the sample size, right, of these empirical calibrations for each interior model, how much it influences that total initial ensemble output is contingent upon the sample size of that initial prediction. So like right there, you saw Diamondbacks initially 60%. It's been hitting at an 84.62. So it's significantly overperforming relative to what the model's initial prediction is, which is great, but the sample size is not massive. So while that 84.62 is certainly going to contribute to that initial ensemble output, how much it influences is relative to how much data that actual empirical win rate, the 84.62, has. Because the more data it has, now it becomes more reliable, because the greater the sample size becomes, there's less variance, starts smoothing out. This becomes now more of a reliable probability. But if there isn't as much sample size, then you know, the how much influence or how much weight it bears in that ensemble output is going to be less. So anyway, Model 3 had the Giants at a 51.2. That's been hitting at a 58.18. So Model 3 will be the Giants at a 58.18. Model 4, Diamondbacks at a 55.26. That's been hitting only at a 48.08. So Model 4, Diamondbacks 48.08. Model 5 also on the Giants, Diamondbacks 56%. That's only been hitting at a 48.39. So Model 5, Diamondbacks 48.39. So we're starting to see a trend potentially of some contrarian signals on the Diamondbacks here, meaning initial predictions are in favor, but those predicted probabilities in reality are not performing well. So that's where the term contrarian or contrarian signal comes from. So now we're going to jump into the back ends of the models. We got Model 6. Diamondbacks initially at a 77%. That's been hitting at a 70% win rate. So good for Model 6 for the Diamondbacks. Model 7, Diamondbacks 62%. That's been hitting at a 57.89. So Model 7, Diamondbacks at a 57.89. Model 8, we got the Diamondbacks at a 61%. That's only been hitting at a 42.11. So another contrarian signal on the Diamondbacks. Model 8, Diamondbacks 42.11. Model 9, Diamondbacks 50.2. That's only been hitting at a 48.89. So another contrarian signal for the Diamondbacks. Model 9 finalized at a 48.89. So all those interior models run, and the relativity of how much weight of those empirical outcomes go into play, 9 models run, and you have your initial ensemble output. So in this case, the initial ensemble output was the Giants being favored at a 51.11. So the first thing you could think then is those contrarian signals that I was talking about had larger sample sizes, which for the Diamondbacks is not advantageous, because you've got larger sample size, low probability ranges influencing your probability. And those high empirical calibrations, like those 70s and 80%, had relatively low sample sizes, so they bared less contribution to the Diamondbacks. So the Giants are initially favored at a 51.11%. So now this is where we bring in that empirical Bayes calibration. And right now, my ensemble model, when it produces 51% probabilities, those have been hitting at a 73% hit rate up to this point in the season. So because of that, again, we still got to take into account that initial output of the 51%. And then we got to take into account that 73% win rate. The sample size makes us rely more on the 73, if not so much. Then we still need to take this into account. There's not significant sample size here because this is my first time doing predictions on the MLB. It's one season. But as time goes on, it'll go like this. Anyway, second layer calibration is now going to make the Giants a 58.81%. So right now, as we're in second layer calibration, the San Francisco Giants are at 58.81. Now we got to assess what market region the Giants are in. So the Giants, the market region they're in, the entire season has exactly a 50% hit rate. So relative to the market, it's indifferent. There's no edge, but there's no disadvantage. This is just a stalemate zone in the MLB sports betting market. Relative to the pricing of the matchup, meaning what the Diamondbacks are priced at and what the Giants are priced at. For the Giants, this is actually an advantage, not so much mathematically because it's 50%, but pricing efficiency or expected value, absolutely, because the Giants are an underdog here and a relatively decent underdog across books, yet they're in a market region that has a 50-50 hit rate right now. Meaning if you made a decision like this in the long run, a team's plus 115 or plus 120, but in the market they were hitting 50% of the time, you would certainly be making money. That's a guarantee. Whereas for the Diamondbacks, who are a favorite, like I think minus 136 or whatever, so their odds vig removed are across most books at least over 56%. Some books getting close to 60%. Yet they're in a market region that would also, as the complement, be 50% for them. That's a decision that would certainly make you lose money in the long run. So we take that market region into account for this third layer final calibration. And what we get is the Giants at a 55.73% probability. So what this does is it takes us full loop back to what the beginning of this video was. Giants 55.73% probability. a plus 18.7% expected value. So very large expected value. Haven't seen this large of EV in a little bit now. Risking 2.75% with a potential profit of 3.1 units. So lock this pick in. Let's get a little roll going. Let's piggyback off of the Reds yesterday. And again, as always, if you want access to all my picks, you can go to my X account at NickTheQuant44. If you want to see what my daily results are, or my highest mathematical edge picks, you can go to my Instagram. I post them there first, and this video comes out. The videos always last, so don't wait for the video. My Instagram, I immediately post whatever the highest mathematical edge pick is. So I would definitely consult my Instagram first. That is at NickTheQuant. So thank you for watching, and yeah, let's get it.